All right, my friends, welcome to another edition of The Issues and You here on your Clear Channel, Colorado Springs and Pueblo radio stations. KCCY, Y96.9, The Beat 96.1, KIBT, My 99.9, KVUU, KKLI, KLIght 106.3, and now we've added to the family with KDZA, AM, perhaps FM, maybe even KCSJ. We've got some of our Pueblo stations in the network now, so hello to all of our friends in Pueblo. My name is Paul Richards. I'll be your host, as per the norm. Our guest today, we are really excited to have him in the studio with us, Dr. Jeffrey Bennett, from right up the road in Boulder at CU. His latest book is called Beyond UFOs. It's the search for extraterrestrial life and its astonishing implications for our future. Dr. Bennett, we welcome you to the show. Thanks for making the time.
Thank you very much, Paul. It's great to be here.
I appreciate you coming down all the way from Boulder. Now, you're in town to speak to some kids, correct?
I'll be over at Odyssey Elementary School this afternoon to talk about my kids' work.
Let me ask you about, we'll talk about the kids' books in a minute, but let me ask you this. As far as groups of kids go, who are the most exciting ones to talk to?
You know, kids are always fun to talk to at any age. And I pitch differently for the younger kids than I do for the older kids because I'm always doing science, so I can do different things with different groups. Certainly, I'd say for me, as they get a little bit older in elementary school, I can do a little bit more in-depth science, so it gets to be more fun. But I love them at all ages.
Well, and you can kind of watch them become little sentient beings right in front of you, can't you?
It is really amazing. It's really amazing to see what they know, even down in kindergarten. They seem to know a lot, and I can't quite figure out where they learned it all.
Well, I'll tell you what, I have an example for you. My son is 9. His name is Spencer, and he had a question for you as well. And his question is, and he's a little bit bent about this, why was Pluto demoted? I'm sure you get that a lot.
It's all politics, you know.
Pluto didn't have enough money to lobby. That was the problem.
But actually, there is a great story there, which is that when Pluto was first discovered in 1930, it was assumed that it was a fairly large object, but like the other planets. But as we learned more and more over time, we learned it was smaller and smaller. And in the 1990s, we started discovering that there were lots of other bodies out in Pluto's neighborhood of the solar system that are not that much different in size from it.
So not fair.
And, well, you know, it was okay for, you know, the scientists were more or less content to say it's still the biggest of that group, so let's just leave it as a planet and not worry about it. But then in 2005, Mike Brown from Caltech discovered this object that we now call Eris, which is in the same relative vicinity of the solar system and is larger than Pluto. So that meant at that point, you couldn't just stay with the status quo anymore. You either had to say, all right, if Pluto's the 9th planet, then Eris is the 10th, since if it's bigger than Pluto, it's got to count too.
Right.
Or you had to say, neither one of them is going to make the cut.
Okay.
And the vote was that neither one of them would make the cut. And that was partly because once you choose those two, if you start to then say, well, what size cutoff would we use, you find there's probably a couple dozen more that would make the cut too. So we're either going to stop at 8 planets or we're going to have 30 or 40 planets. Well, and I have some friends in the science community who want the 30 or 40, and they're still lobbying for it, and they'll probably come up to vote again.
Well, and once you get to Jupiter, I mean, some of those Jovian moons are every bit planets.
Well, and in fact, that is another tricky part. Some of those are larger. There's 2 moons that are larger than Mercury. And the only reason we don't call them planets is because they orbit a bigger planet. Mm-hmm. So it does become a semantic issue. Nature doesn't always fit into our nice little categories that we make up as human beings.
Like we would like it to.
That's right.
Well, listen, let's talk about Beyond UFOs. A great title for a book. How did you come up with it?
Oh, thanks very much. You know, the title came to me pretty early on in the process. I had written a textbook on the search for extraterrestrial life. Astrobiology is what we call it. And I wanted to do something for the general public, and I thought, well, what are we really doing here? Because we know that the public is fascinated with extraterrestrial life.
Absolutely.
But most of
the box office receipts certainly bear that
exactly.
out.
And when you think about that, the first thing that comes to most people's minds is UFOs. And
sure.
What do they mean? So I thought, well, what we're really doing with the science is we're going beyond UFOs. We're not stopping at the things that people might imagine, whether they're real or not. We're going beyond that into the things that we can actually study scientifically. So beyond UFOs came pretty naturally.
Well, and you take it beyond UFOs in that you deal with the possibility that perhaps we're being visited, and you also talk about life itself and the nature of life itself and how it might constitute itself away from the Earth.
That's right. There is that possibility that we're being visited. I'm skeptical of the UFO reports myself, but we can't rule them out. But there's still things that we can talk about scientifically even there, and then we can go into the detailed science of the biology, geology, chemistry, and the actual search for life in the universe.
And that's why this is such a fascinating time in astrophysics, because, I mean, what's going on up in space right now, even as we're speaking, our astronauts are up there on the shuttle trying to fix the Hubble Space Telescope to make it even better.
Right, and they're repairing a couple of things, and they're putting in new instruments which were by design to upgrade its capabilities. It's like upgrading your software in your computer, but here we're actually upgrading the hardware on the Hubble Space Telescope. And this is particularly exciting for me, coming from the University of Colorado, because, all five, after these new instruments are put in, all 5 instruments on the Hubble will have been built by Ball Aerospace in Boulder.
Very nice.
Very nice. And also I have a personal connection that the cover of my textbook is up there in space.
Wow.
Right now with one of the astronauts, John Grunsfeld, who's a friend of one of my co-authors. So
How
then we all get
cool
to fight
is
over who
that?
gets the one that's flown in space.
That is so cool.
I'm pretty excited.
You should be. That is just remarkable. Now, once we get the Hubble back online, and I'm very confident that the mission will be a success, we're looking back now maybe 14 billion years to the very beginning of the universe?
Well, Hubble is able to see, it's sensitive enough to see things that are bright in visible ultraviolet near-infrared light all the way to the cosmic horizon, 14 billion light years away. However, as you get really close to that, there's no longer things that are bright in visible and ultraviolet light, because their light, combination of things. One, their light would be so redshifted that it starts to move into the infrared. Mm-hmm. And second, you're into the era when stars and galaxies were just beginning to form, so they hadn't quite turned on yet. So Hubble can't quite get to those things that we would really like to see, which is why we're working on the next generation James Webb telescope at the moment.
Now, what's going to happen when that comes online?
When that comes online, we'll have much stronger capabilities in the infrared, which will allow us to see these things very close to the cosmic horizon when stars and galaxies were first being born, and really start to get a handle on what was going on in the very early universe.
Wow, it's so exciting. So exciting.
It's amazing stuff.
And you postulate about what happened before the Big Bang, and you realize that there are any number of theories. One of the recent ones that I have heard are that we are engaged in a group of bubble universes, perhaps. And the two of those have kind of cosmically hit one another, collided, and that was the genesis of our universe.
There's a lot of ideas around
There's a lot out
the
there.
Multiverse.
Yeah.
Star Trek covered it years and years ago.
Gene Roddenberry was so ahead of the game. And the multiverse is a possibility, at least. Right?
It's a possibility. Now, one of the things I like to do personally is distinguish between what counts as science today and what counts as speculation today.
Mm-hmm. Okay.
And this is one of those places where it's gray, because it's real scientists who are studying the multiverse. They're working out the mathematics of it. But what they're really doing at this point is saying, how could we actually test observationally or experimentally for this possibility? And in fact, at the current time, we can't. They're looking for ways that we can. So for the moment, it remains in the realm of speculation rather than what we usually think of as science, because we can't yet test it.
It is based on observation.
It's
not based on observation.
It's not based on observation
Right.
and experiment. It's based on extrapolation of mathematical ideas that we should be able to put to the test in the future.
Hopefully.
So at the moment, I don't quite think it stands up as real, true science. It stands up as speculative ideas that may become science if we're able to test them.
Well, and speaking of ideas that were once science fiction and are now science, I read a passage in the book just before the show talking about in 1919 when Edwin Hubble and Milton Humason were doing their work in California, we didn't know if there were other galaxies. And this is just 90 years ago. To think the quantum leap we have made in just those 90 years, it does give one hope for the human species, does it not?
It certainly does. We've just made remarkable progress. Another place I like to talk about that in the book, I talk about our landing the Huygens probe on Titan in 2005, which is the equivalent, just to hit Titan from Earth is the equivalent of firing at a dime from across the United States and hitting it. And we didn't just hit it, we landed softly on this thing 1 billion miles away, which is just a remarkable testament to what humans can do when we put our minds to doing constructive things.
Exactly. And I hope that these are the kinds of missions that will actually inspire people to get more involved. I mean, we have India looking at manned missions. We have China looking at manned missions. We have the International Space Station. So at least some of these resources that perhaps have gone to questionable endeavors in the past are now going forward to scientific endeavors that may benefit all of us.
You know, one of the really amazing things, again, I think I talk about this in the book a bit, is if you look back to Apollo 1, which was when we had the largest budgets for space, adjusted for inflation, still about 5 times what we're spending on NASA right now.
Wow.
And at that time, it was really a Cold War type of thing that made us go to the moon.
Mm-hmm.
And yet, when we got there, what was the first thing the astronauts did? They said, we came in peace for all mankind. So even that, in the middle of the Cold War, showed that space could be used to unite us and to inspire all of us. And I hope we'll be doing a lot more of that in the future.
And did you think, Dr. Bennett, that by now, by this late date, 2009, 40 years after Apollo, that we would perhaps have a manned mission to Mars by now?
Yes.
I know. It's one of those difficult things.
I think I tell the story in the book, too, of how my grandfather took me to see 2001: A Space Odyssey in 1968, a year before the first moon landing. And afterwards, he asked me what I thought of the movie. Did I think it was realistic? And I told him, no, it was not realistic at all. And he said, why not? And I said, because it's 2001 and they haven't even finished that big space station and they haven't even gotten to Jupiter yet. So I thought it was ridiculously under-predicting the future. And, of course, it's turned out to be the opposite, much to my disappointment. So, yes, I thought we would have been much further along by now, and I hope we will be able to make up for lost time.
But there are some severe limitations in us traveling that far, are there not? I mean, the bone loss and radiation, the possibility of exposure to radiation, are just two of the myriad dangers that await us.
There's certainly a lot of biological difficulties in sending people to Mars, which is one of the reasons why I personally think we need to go back to the moon first, which is what NASA's current plan is. I think we should do it in a more international way than NASA is so far doing it. As you mentioned, the Chinese, Indians, Japanese, Europeans are all talking about doing the same thing. Why not do it all together? But I think going to the moon first, going from there to Mars, and one of the reasons I believe in that, and I talk about this in the book too, is because the moon is a destination that is in principle reachable. The way we're really going to get space to open up is with commercial ventures, with space tourism, with the university that we put out in space. And the moon is a place that, in principle, if the tickets were cheap enough, you can go there over spring break. It takes 2 days to get there, spend a week on the moon, come home. Mars is a 2-year trip because you have to get there, which takes a few months, and then you can't come home until the orbits line up again, which is a 2-year prospect. So I think the moon has a lot of great possibilities for opening space that Mars is more limited on for the time being.
And so we would have to extrapolate then that journeying to the outer planets and beyond the solar system is way in the future.
Will be even more difficult. Of course, Mars offers the scientific prospect of looking for life, which gets us to that whole idea of what are the prospects for life in the universe.
Yes, and let's talk about that. What are the prospects? I mean, a lot of us amateur cosmologists know about Drake's equations and those kinds of things that are basically formulas to try and give at least a number to an estimate as to how many civilizations might be out there, how many planets might be holding life. But what's realistic, Dr. Bennett, really?
Well, I think that you like to break down this search for extraterrestrial life into different subcategories. So the first one is the search for life in our own solar system. And there we know we're talking about primitive life, probably only microscopic life, although there's possibilities of bigger things swimming in the ocean of Europa.
Sure.
And so on.
I saw 2010, I know.
Right. We're not going to find intelligent life here in our solar system because if it was there, cities and so on, we would have already seen it. We've surveyed all the planets in depth. Then when you look beyond our solar system, now you have the possibility both of looking for simple life, like we might find elsewhere in our own solar system, and the possibility of looking for advanced life, intelligence, and the search for extraterrestrial intelligence.
Now, might we also find life that is perhaps based, and this has been postulated in science fiction for years as well, that we might find organisms that are based on elements other than carbon?
That is certainly a possibility, and yes, science fiction has speculated about all sorts of incredible forms of life. Now, scientifically, and I'm dealing with the scientific search for life, we really don't have the capability of searching for anything besides carbon-based life right now because we don't know where we would start. It doesn't mean that we shouldn't be looking for ways to search for it and do the search for it, But for the moment, if we're looking for biochemical signatures of life and so on, we're looking for carbon-based life. Now, of course, when you go to the search for extraterrestrial life, extraterrestrial intelligence, there we're looking for signals. And so if a silicon-based life form or some other based life form is signaling us, we could still pick that up.
Still understands what a radio signal would be.
That's right.
And what would constitute it. Now, honestly, Doctor, do you think that there's a possibility we may intercept signals at some point, or we might get a reply from somewhere?
It's certainly a possibility because, as you mentioned the Drake equation before, when you run through the numbers, and a lot of the book is devoted to talking about what are the possible places for life, where might we find intelligent life, what's the likelihood that it would evolve and develop. And when you look at all those numbers, we really can't say anything definitive. It could be that intelligent life's extremely rare, we're the only ones. It could be that it's really common, but when you go from what we know of the science today, it just seems like there ought to be thousands, hundreds of thousands of civilizations out there. So if there are, then they presumably would have gone through stages just like we're going through now, have developed radio technology, have developed space technology. And so, yes, the possibility of getting a signal from them seems quite real. And that's why I think SETI is a worthwhile effort, even though we can't predict the chances of success.
Well, and we did have the one moment back in the day where the signal came in and, maybe just for a second. But then we decided it was a natural occurring phenomenon.
Well, and there are a couple of signals that are not fully explained, but they have been intermittent, and in science, we're looking for reproducible things.
Consistency.
So without more data, we can't be confident of what it was.
So as we make the search for life within our solar system, we go to Mars and we go to the outer planets, and maybe we check out the moon as well. What do you see as the chances of finding something biological on, say, Europa?
Well, I think that the places where it seems like there's a good chance for life in our solar system are first Mars, second Europa, because we're pretty confident that it has this deep ocean under the surface. And then there's several other places beyond that might also have subsurface liquid water, including Ganymede and Callisto, also moons of Jupiter, Titan and Enceladus at Saturn. But certainly the top two are Mars and Europa. And for the time being, we do not have any mission that will be able to get to Europa and go into the ocean, although in my children's book that I'll be talking about at the school today, Max Goes to Jupiter, they do, in fact, put the submarine down and have it melt its way through the ice.
Now, is that a new Max book?
That is the newest Max book, yeah. He went to the moon first, then Mars and now to Jupiter.
So working his way out into the outer regions.
Working his way out, so we're looking for life on Europa. But for the moment, our only place where we really have the capability of searching for life directly is Mars, and even there, we're not quite at that yet. We're looking at the conditions on the surface. We're not quite really searching for life underground. But hopefully, within 10 or 20 years, we'll be able to do that.
Well, let's also talk about what happens. What is Hubble's role in all this? Is Hubble going to be able to give us some of those chemical signatures from some of the outlying galaxies that we might, or outlying solar systems that we might need to see?
Unfortunately not. Hubble is not big enough to be able to see planets around other stars and get a spectroscopic data from them where we could be looking for that. That will fall to later generations of telescopes. But what's really exciting right now, you mentioned what's up in space right now, the astronauts working on Hubble, but also just a couple of months ago, the Kepler mission was launched. And what that should be able to do here over the next 4 years is discover planets as small as Earth around other stars. So we should know definitively the answer to the question of whether other Earth-sized worlds exist by 4 years from now, thanks to Kepler. Now, it won't be able to study those planets, take pictures or spectra and look for life, but once we know they're there, that I hope will spur the next set of missions that will be able to begin to look at spectra from these planets.
And it's fascinating. I mean, we hear about the gravitational wobble, and we hear about the chemical signatures that show that we have Jupiter-sized planets in close orbit to some of their suns. How exciting is that? Just to know that similar structures of solar systems are out there.
Well, it's remarkable. You can go back 200 years to Immanuel Kant theorizing that planets would be common because of the way they formed, but it was only in the last 50 years or so that we learned that his basic idea was actually right, that planets form in these clouds of gas that swirl around stars. Now, just as of 1995, we got the first real proof that other planets actually exist around other stars, showing us that we've got the basic idea correct about how solar systems form. And the next part that falls out of that is that it shouldn't just be big planets, but you also should have Earth-sized planets forming. But do they really? Are we right? We don't have the proof yet, but we will within 4 years.
And those
Kepler.
And those early scientists had to go out on such limbs. And it proves to me and reinforces the point to me, Dr. Bennett, that we are still a child race, a child species, and that we really need to watch ourselves, particularly now as we continue, to make sure that, A, we keep our clarity about what our real purpose is going forward, and the fact that we need to take care of a good old Mother Earth here while we're at it.
That's right. And as I discuss in the book, I like to think of us as a adolescent civilization. We were children, and when we were children, we couldn't really hurt ourselves. But if you think of us in the context of all these civilizations that could exist out there that would be far more advanced than us, they're the grown-ups. They've made it through the turbulent teenage years. But we're right in the midst of that adolescence where we're beginning to get the technology and the ability to go out into space and join the grown-ups. But also, we have these impulses that aren't always in our best interest. Sometimes we don't think about the future hard enough, and we do things that might not be in our best interest even when we're not thinking about it.
Maybe we throw a tantrum.
We throw a tantrum.
So what's the key then to evolving to our next level as a species?
My personal belief is that the key lies in education and getting everyone to be thinking about where we can go. And I give, again, the analogy with a teenager in adolescence. We have lots of problems, just like you might have a troubled teenager. And the way that you get a troubled teenager to overcome their difficulties is not by locking them in a closet and saying, come out when you're ready to behave. It's by showing them why better behavior is in their own personal interest, because it will help them make the life they want as a grown-up. And in the same way, if we can have everyone on Earth look out and see the incredible possibilities that are awaiting us out there, what amazing things there are in the universe to learn about that we can all share, whether we go personally or not, that is what I think will help people say, you know what? We should all be working together on this. We shouldn't be fighting over petty things. We shouldn't be wrecking the planet we have. I think that even when you go to things like terrorism and so on, you're dealing with people who are not well educated about the possibilities. And so the idea of just believing you're the center of the universe and you can do whatever you want maybe comes too naturally to them. If we could find a way to educate everyone around the world about these possibilities, I think we'd see all those problems get better.
Speaking of possibilities, Doctor, let's talk about the possibility of encountering extraterrestrial life in whatever form. What would the implications be?
Well,
there's the big question, huh?
That is the big question, and that's why I subtitled the book, and it's Astonishing Implications for Our Future, because the implications are truly astonishing. And of course, again, it depends on what type of life you're talking about. Mm-hmm. It is astonishing if we find even microscopic life on Mars, because it would prove that life gets started pretty easily. If it happened in 2 out of 2 likely places in our solar system, that's pretty strong evidence that life is easy. If it didn't happen on Mars, then you're still left with the question of, wow, how rare is life? But I think we probably will find it. Now you go to the question of, what if we get a contact with an intelligent civilization? And there, now you've really blown everything wide open, because that means not only that life is common, but that we are just part of a much larger whole in the universe with other intelligences out there. The immediate effects on human beings, who knows? Carl Sagan did a wonderful job talking about what that might be in Contact, the book, and then the movie that was made from it. But I think certainly it would be the most astonishing discovery in human history. It would be the next step in the whole Copernican revolution, where we first learned that Earth was not the center of the universe. Then we learned that our solar system was not the center of the galaxy and the universe. And to find out that we, as a species, are not the only intelligent thinking beings out there would be an incredible change.
And I want to talk, too, about the evolution of the universe itself, because that is an ongoing process as well. We, as a galaxy right now, are on our way to Andromeda, whether we want to be or not, and at a really remarkable rate of speed, which escapes me at this point. But it's remarkable. And we are eventually going to collide with the Andromeda Galaxy. And those are the kinds of things that, in the big picture, really give pause, I think, to our place in the universe. Because these are events that are so massive and yet virtually undetectable by people like us. It's going to be amazing to see what those kinds of events in the future, what kind of impact they have.
Certainly the universe is so big that it makes you, it really changes your perspective on everything. And of course, it can be a daunting thing to think about. Some people tend to get depressed when they think about how large the universe is and the fact that we have no control over those kinds of things. But Carl Sagan used to talk about how it shouldn't be depressing at all. It should be inspiring that in this incredible, big, vast universe, we are capable of knowing about it and figuring out. We are the universe's way of knowing itself. And so I think that it's not depressing at all. It's inspiring about what our capabilities as a species are. And I think the more we learn, the more inspired we'll become.
How do you see the future shaking out as we continue this path? Do you think that eventually we're going to leave the solar system? I mean, I'm of the opinion, Doctor, and once again, this is just one amateur's opinion, but one of the primary jobs of a species is ultimate survival. To that end, do we not need to be looking 3, 4, 5 billion years into the future when the sun runs out of fuel? And as Carl Sagan put it, there will be that one last perfect day on Earth. We need to think about survival long term, and I think we need to start thinking about those kinds of things now.
Well, I think I would probably come down on the side of there's a long time. Billion years is a
Thankfully.
really long time. And I think we have survival issues that are much more immediate that we need to deal with, and the others will take care of themselves.
I hope that's true.
Or our future generations will take care of them if we get them to that point. But certainly, I think that what we do need to be thinking about is how do we solve our current problems? How do we deal with the fact that we have terrorism threatening us? How do we deal with the fact that we have nuclear weapons threatening us? How do we deal with the fact that we have global warming threatening us? And you'll see all these things are major topics in my book and Beyond UFOs, because we cannot go to the next step, even just making contact with someone or going out to the moon and beginning that process of moving out toward the stars. We can't go anywhere unless we solve these problems now. But my argument is that it's not enough, again, the teenager in the closet, to just say fix them. We must be devoting resources at the same time to looking at those next steps so that people around the world will be inspired. I like to think about that moon colony again. Mm-hmm. We should have an international moon colony where people from every country of the world are working together. You know, we do have scientists, astrophysicists in every single nation on Earth, even the places that you think of as the most extreme Islamic fundamentalist republics still have working astrophysicists who are not in that fundamentalist mode. They're in the mode just like the rest of us. Let's get them all up there working together on the moon so that the kids in those countries can look up at the moon at night and say, you know what? How come they're all working together up there and we're having so many problems down here? Maybe we should be doing something different down here. I think we would see a major change in the way kids everywhere in the world think about us as a species, and it would be a change that would be very positive.
It would be a sea change, and one I hope I live to see. Dr. Bennett, it's been fascinating. Before we wrap up, how can people get a hold of the book Beyond UFOs, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future?
Well, I'd really like to have everybody come visit my website, www.jeffreybennett.com, JEFFREYBENNETT.com. And from there, you can link out to my kids' website and also the Beyond UFO website, which is just beyondufos.com.
Excellent. Well, it's been a delight, and I hope we can do it again real soon.
That would be wonderful. Thanks so much.
You bet. Jeffrey Bennett, Dr. Jeffrey Bennett from CU up in Boulder. His book, Beyond UFOs, A Search for Extraterrestrial Life and Its Astonishing Implications for Our Future. It is available on Amazon and probably at your local bookstore as well. And we certainly thank him for coming down, spending some time with us here on the program. And we thank you as well for being here for another edition of The Issues and You here on your Clear Channel, Southern Colorado radio stations, KCCY, Y96.9, The Beat 96.1, KIBT, My 99.9, KVUU, KKLI, and also the KDZA family of stations down in Pueblo, maybe even KCSJ, KDZA. So thanks very much for listening. We'll talk to you again on the program next weekend.